In this lesson, we'll explore several important properties of logarithms. For any positive number b with b not equal to 1 and any positive number y, the following properties are true. First, the log base b of b is equal to 1. To see why this property is true, let's look at the corresponding exponential equation. We know that the exponential equation b to the 1 equals b is true. And in logarithmic form, this just becomes log base b of b is equal to 1. So from the valid exponential equation b to the 1 equals b, we get this logarithmic equation, or this property, for any base b, the log base b of b is equal to 1. Our next property is that the log base b of 1 is equal to 0. And again, we can see why this is true by starting with a valid exponential equation and then writing it in logarithmic form. So we know that for any positive number b, so for any base b, b to the 0 is equal to 1. This is one of our properties of exponents. And in logarithmic form, this is just log base b of 1 is equal to 0. So far the two properties that we have are log base b of b is equal to 1 and log base b of 1 is equal to 0, and we were able to see why these properties are true by looking at the corresponding exponential equations. Our next property is that b to the log base b of y is equal to y. Now, to understand why this property is true, let's take a look at, again, converting between logarithmic and exponential forms. So we're interested in b to the log base b of y. Let's denote log base b of y as x, and that means that we're interested in finding the value of b to the x. So we want to know what b to the x is equal to. Well, writing log base b of y equals x is the same thing as saying in exponential form that y is equal to b to the x. So this is just our definition of the logarithm. So our b to the log base b of y, this is just b to the x, which we know is equal to y. So b to the log base b of y is equal to y. And our final property, which is similar to this one we just looked at, is that the log base b of b to the y is equal to y. And again, we can look at this by looking at the corresponding exponential equation. B to the y is equal to b to the y. In exponential form, rewriting this in logarithmic form tells us that the log base b of b to the y is equal to y. So these final two properties tell us that the exponential and logarithmic functions are inverses of one another. So b to the log base b of y is just equal to y, meaning if you take the log base b of y first and then raise that to the b power, you just get back the y that you started with. And similarly, if you start with a number y, compute b to the y, and then take the log base b of that result, you just get back this y that you started with. So the exponential and logarithmic functions are inverses of one another, and we'll explore that property in more detail when we go on to study functions in more detail. So if the key from this lesson is these four properties of the logarithms. For any positive number b with b not equal to 1, the log base, and any positive number y, the log base b of b is equal to 1, the log base b of 1 is equal to 0, b to the log base b of y is y, and the log base b of b to the y is equal to y. And to prove all of these properties, or understand why all of these properties are true, we look at the corresponding exponential equations.